So welcome everybody. My name is Markus Grau. I'm in the office of the CTO, located here in Germany. I've been with Pure over 10 years now, so I was one of the first employees in the DACH region when Pure was a tiny startup back in 2013. And to be honest, I was attracted by the vision of, hey, we can make an full-fledged data center, make it a reality. Which was a bold statement over 10 years ago, because Flash was seen in a very niche market, in a high performance market, but as you see, it has now turned down to, it's the de facto standard for storage in data centers. You might be familiar with my colleagues in EMEA. I'm in the same group as Fred Leroy, Patrick Smith. You might be familiar with these guys already. And today we want to talk about, okay, what do we mean with a data storage platform, what we're bringing to the table, and also dig into why we think flash storage is going the way forward, even for workloads which have not been the usual, I would say, the usual case for flash media these days, and how we change operational behavior for the whole life cycle of the storage operations. So I was asked to put a summary slide in front because that's what we're basically talking about. And that's, in a nutshell, what the Pure Storage data platform brings to our customers. So you see we got some infrastructure platforms and tools and software and SaaS offerings which help operating these platforms in a very efficient way. And there are some outcomes which have been there from, to be honest, from the beginning of the company itself. So we wanted to make storage simple. We questioned everything in the storage industry which was hard and tried to solve the hard problems so our customers don't have to. And that led to a very common hardware and software platform, and I will dig into that a bit deeper, what that means to have a common software and a common hardware platform. The outcome is also, these days, especially in Europe, the theme of sustainability is an important one. There is no company without a sustainability agenda. We have some trends in the industry which make it even harder to follow that agenda these days. Just to name one is AI, which is the elephant in the room for probably every vendor presentation these days. But in the end, how can we contribute as infrastructure to the sustainability goals while driving AI initiatives and customers? Other things like, which also leads to the security piece, is how can we have a very resilient infrastructure, and not just resilient in form of data availability, but also on how can we make the best out of it against cyber threats, how can we protect data, how can we make it possible to recover if something bad happens, how can we solve these problems as well. And you see it's also an efficiency play. It's not just sustainability, but also efficiency, which drives things like, or which are driven by simplicity aspect, right? Because in the end, if something is simpler, if something is more sustainable, you need less labor to operate it. And last but not least, infrastructure is often seen as a burden for new initiatives because there is this thing called technical debt. And we try to have our customers enabled not to have any kind of technical debt in the infrastructure, which means, hey, if you buy into Pure, your investments will never get obsolete. You will always stay ahead of the curve in terms of features, in terms of driving your initiatives, and not falling behind because you have to, for example, replace parts of it and do age-long migration projects. So that's the high-level slide. For those of you who haven't seen the latest numbers, we just announced I think it was 2 months ago, our Q4 numbers for the last fiscal year. So we are almost at 3 billion of revenue. And what you can see is there's a trend here for subscription services. And that's a theme we're driving as well, and customers are demanding it, is to go from a classical purchase cycle. I buy infrastructure for 3 years, 4 years, 5 years, and then rip everything out and get new stuff in, to a more, I would say, cloud-like operating model, also from a purchasing perspective. And that also,
Is that subscription model per use? If you take a subscription and don't use any of the stuff you've just bought, can you claim your money back?
Good question. And there are different subscription models we offer to customers. So it's all under the evergreen umbrella. So that's the term we're using, because it just gets better over time. That's the reason. So first of all, you can have I would say, a classical purchase where you have a software and hardware subscription. So there you don't get the money back because it's just subscribing. You can own the hardware. That's another subscription piece, but just pay for what you're using on that. So you pay basically the software feature set per use. So if you don't use it, you don't pay anything. Okay. And the last piece is under the name is Evergreen One, which is a pure subscription model as a service model. So that means you're not buying hardware, you're not caring about boxes in the end, you're subscribing to SLAs. So we give you an SLA which says how many IOs per terabyte, how many watts per terabyte, terabytes per watt in that case, how much do we get out of the watt or power consumption, and then it's pay per use. And here it's really meant to flex up and down in very flexible terms. So it's not a lease model, it's really a model where you say, okay, I need whatever 500 terabyte of storage class X, I subscribe to that SLA for 12 months, as an example. And then you can have buffers where you can grow into. And if you decide, okay, for the next cycle, I need less because I'm, for example, moved some stuff over to public cloud or whatsoever, then you just have a contract with less data.
I think I like that. I think I've met other people who've offered a subscription service where the minimum subscription is 5 years and you pay for 5 years regardless whether you use it or.
Yeah. So and that's something we try to change. So subscription services really start with the tier which is 50 terabytes and a 12-month contract. So it's not that we tie you into a 5-year contract, which is in the end just a financial model in the end. Around that, it's really a as a service, and it's not just that we give you the hardware and a sticker on it, which is called as a service. It comes with additional services we will see later, which these services are, because in the end, we think that, for example, it's our responsibility, for example, for energy efficiency, if we offer a service to a customer, and not just put that into the customer's responsibility because we ship them already written on hardware, as an example. So we try to change that. What's interesting here is, that's the one and flex models, which I described. That's the pure storage as a service model, and the one where you have we own the assets but subscribe to the service. There's over 100% growth, so customers are denying it. The other piece is, which is honestly hard to maintain. It's easy to get a great net promoter score if you're small, because customers like you, probably because you're solving a specific problem. It's getting harder if you're growing and have more and more customers, more and more features, which also is prone to, I would say, complexity in some way, and to maintain a great net promoter score. And that's an audited score, so that's not just made up internally, that's externally audited, and that just, I would say, gives you a perspective how happy Pure customers are in general. All right. So since the inception of Pure, we're obviously growing. We're not that 40-year-old company yet. We're turning 15 in October this year, but we've made it to 60% of the Fortune 500 customers using us. And here are a few examples. You might be familiar with these brands, and it's not that we have small estates in these companies. Sometimes it's just also partnership with Equinix, which are offering services based on Pure's offerings as well. And technology partnerships like with Micron, you see that, for example, that's a flash vendor. We're still growing, and you see the storage market itself is growing, not that much as it has been, so it's in the single digits usually. But what we do is we're taking constantly market share from the big vendors here. And these are the IDC numbers from 2014 to 2023. And what you can see is we're on a constant growth curve. So in the end, we're taking market share, and obviously we want to take more, right?
One question: what are the reasons, in your opinion, why the others going down, but are not even stable?
Well, we have some big changes in the industry, right? And one is, well, the transition from disk to flash, and we drove that change as Pure. I would say we were the driver of the whole transition from disk to flash. We said it's possible for every workload, and the others are following. However, they have not every vendor has an architecture based on flash. They have legacy architectures, which are, quite frankly, harder to move over to a new medium, to make it as efficient as Pure. And vendors are trying it, but we will see there are some good data points where they fail. The other thing is the complexity piece. Everyone has built its business more on IT and more digital services, and they are complex to implement. And we make the infrastructure piece very simple to operate. While, for example, other vendors are still dealing with complexities, huge portfolios. You've seen in the end, we have two hardware platforms which share very much commonalities between each other to serve the whole market, instead of having a box or a product line for each problem. And this is something which is very attractive for customers because it simplifies everything.
Why did you not include Claudium? They also move into a flash market.
Well, Claudium is not a flash vendor, and they're not a primary storage vendor.
Oh,
They're not seen from an IDC perspective in that chart.
I see.
So this is always, you see that the enterprise storage systems tracker, that's the IDC, and Claudium is not in that tracker.
You said flash. Is this only the flash market, or is this
That's complete storage.
a complete storage?
That's complete storage. But it's enterprise storage, because how IDC and Gartner are segmenting the markets is a bit different.
I don't really like this kind of things because it doesn't say what you measured and how you measured it, and it's kind of like,
That's really just market share growth in the enterprise storage market.
Right. Including services, hardware and software, people. You never know.
No, it's not. It's how IDC measures market share. Yeah. Okay.
Can we skip that?
Can get to another one. That's basically that's the money side in the end, because
Follow the money.
this is what IDC tracks in the quarterly enterprise storage systems tracker.
but also
That's the all-flash market share there.
Yeah.
Okay, that's a different beast.
It doesn't include hard drives.
Yeah, because it would be completely different if it included hard drives.
It will be a bit different, yeah.
Yeah.
But you wouldn't, since vendors are, I would say, transitioning to flash. I don't think it's that. Yeah.
In the enterprise storage market, are there the cloud providers also included?
No, they are.
Okay.
What exactly, it's probably a silly question, but what exactly is storage? I mean, you've got people using the vast mainframe databases. Does that count as storage?
No, it's really storage systems in the end.
Yeah.
So also I think
database is not a storage system.
no, it's software. That's a system is I think defined by IDC as a combination of hardware and software.
Okay.
Sold as one piece.
Oh, okay. So, because I'd have thought the large database running on an IBM Z was a storage system.
Well, but IBM Z, for example, has an external storage system attached to it,
Yeah, okay.
which then goes into probably this bucket for IBM.
Okay.
And it's usually IBM Z system that's hard supported by instance.
So one storage system is counted every time for every vendor, but it could be that Dell EMC has zettabytes of data, you only have petabytes of data.
Well, that's revenue numbers from IDC where they track the market share.
Indeed.
And that includes the whole portfolio, which falls into the enterprise storage. So this is for us, it's our product line. For Dell, it's the whole portfolio of storage what they have.
Yeah, I understand, but it's not about the numbers of how many data is stored on those.
No, it isn't. No, I think IDC tracks revenue numbers.
Okay.
Well, you might have said just to say one of the big three or something like that.
Yeah, but think of it where we started 10 years ago, and that's quite an impressive achievement to now be on the second spot for Q4 as well as for the whole year 20.
Getting again the last comment on that slide that you wrote onto the technical stuff. And that in a way it could be misleading because you could be providing better density, more capacity at a cheaper price point, and therefore the revenue that you're getting doesn't necessarily reflect the capacity that you're delivering to the users compared to what Dell or IBM or others may be delivering, right? So it's kind of, numbers, you can't tell anything about that, but it could be in the fact due to the optimization that you have provide much more capacity than some of your competitors.
Okay. It's always what do you present? Because if we would present a terabyte shipped, it's a different beast. And if you compare revenue with profit, etc., it's always what you do. But this is what IDC is doing, right? Okay. For the EMEA market, which is interesting, is because we're a US company, and usually US companies tend to focus on the US market, and then there are other markets as well, which are following. And especially in the EMEA market, we see that the adoption of new technology is a bit slower compared to the US. And that's an EMEA number of storage market growth. So the EMEA market last year grew just 2%. But we grew 24.8%. And that's also a reflection into the slide 4 about market share. Because we're growing way faster than the market is growing in the EMEA market. All right. So, why are we doing that? As I said, it's not something where we have a silver bullet now or a whatever feature. It's a strategy which we set up from the beginning. And we started obviously with a single product, but evolved that into not having a product, but also wrap a business model around it. And that's the evergreen deals. And it really started with a thing called non-disruptive upgrades. And what we mean by non-disruptive is you can have a system from 2011 and upgrade it to a system with brand new technology for 2024 without any downtime, without any performance degradation. So it's just like, okay, you hit F5 in your browser, in your application, and boom, you get something.
Must be somewhere ahead, surely, of converting format. Must be somewhere ahead of converting formats or something. I mean, you may not, if you've got enough capacity, it may not show up as a defect on performance. Like, imagine a system that was marginally well specified, hitting problems just because of the extra load, extra processing.
Well, in the end, we put a lot of R&D money into that capability.
Yeah.
Because that's one of our unique selling points is in the market. It's because, yes, you're right, we're changing layers. We're constantly improving the platforms. As an example, we just give customers more effective capacity with software upgrade because we optimized something. And we're rolling out to the whole fleet because it's just a non-disruptive.
If you optimize, there's always a chance that you become suboptimal for some other case. If you optimize for a particular case, there's always a chance to become suboptimal somewhere else. So you can never be sure that optimization is going to deliver results until you test it.
Well, and that's the thing where, for example, the Pure One platform comes in. Pure One is our software service-based monitoring, analytics, and support platform, which also ties into, we have a huge data repository back from telemetry data of our customers. Now, these arrays are becoming, I would say, endpoints, IoT endpoints, and we have a large warehouse where we're using machine learning and AI and stuff like that to do analytics on the workloads, on the behaviors of how the systems are behaving in a customer's environment, and then we can optimize. And that mitigates the risk of, hey, I optimize here and it falls down somewhere else.
And that's presumably on operational data, not on customer actual data.
Yeah.
So
We never have insights to customers' actual data. It's just for example, data patterns we see.
Yeah.
So we can spot, okay, this is probably a workload driven by an Oracle database because Oracle databases are behaving like this from our old data, as an example. Or we see this, hey, that's application X because we know application X has this read-write ratios, this block sizes, etc. Now, and obviously, the more data you get, the more accurate it gets in that case.
Sorry, could you give an example, please? Like, I assume it's the evergreen non-disruptive upgrade. It's not an upgrade in size. Some
It can be,
yes,
doesn't have to. Yeah.
yeah, but that would be the easy one. When you talk about upgrades, you mean like upgrades in functionality, what it can do to the system.
Well, if we're talking non-disruptive upgrades, let's start with the simple things. It's capacity expansion. That's the simplest thing, to just getting more capacity, right? And it's immediately recognized. It's just one single storage pool and no silos in the storage system, so that's the easy one. Non-disruptive upgrades does also mean capacity consolidation. How to consolidate from, I say, that rack space of the smaller drives to that 3U rack space, larger drives, non-destructive, without external data migration.
And we're talking on the fly.
On the fly?
The whole system is running.
Yes.
Go another.
Most systems have 100% uptime, including software upgrades, including hardware upgrades, including hardware generation changes. So you can literally get a system now from 10 years ago, give it a name, have data on it, and change every piece of the hardware, every piece. Have a new system on the fly while doing full operations.
Yep.
Including, because 10 years ago, we had a different software version, including several software updates during that time, maybe hardware interim steps you have to take to cover 10-year-old system. But it's on the fly, it's non-disruptive. And we changed so much technology since. I will go into that a bit. I think that will next.
Yeah.
I can give you a good example of what we changed, and because, as I said, we're investing a lot of our R&D money into that capability, because that's what customers want to have. 24/7 operations at the same SLA. No performance drops, no outages, no notifying hundreds of customers, hey, there will be a performance degradation or whatsoever from 2 a.m. to 6 a.m.
I got it with Ben.
All right, so a few other data points. Well, AI is today very dominant and popular especially in the media. I think that was 2017 or 2018 where we brought the first AI-ready infrastructure out together with NVIDIA. So that's a turnkey solution which consists of NVIDIA GPUs, NVIDIA switching, and pure storage. And it's a certified reference architecture, which now becomes, let's say, more popular in terms of this, what's called the NVIDIA-based board certification. It's just make sure that components are working well together. They can be sold by big markets, for example, to get implemented. So you get AI-ready infrastructure. So the infrastructure people don't have to care about the AI part, and the AI people, the data scientists, don't have to care about, hey, what kind of infrastructure they need, because they have literally done it right.
What sort of problems do you hit with a structure that's not AI ready? What's the benefit you're getting? If it wasn't AI ready, what effect would you see?
Well, we have to go back a bit in time, because AI largely meant, okay, that's more in the HPC, in the high performance computing space,
Yeah.
where lots of stuff was really done manually.
Yeah.
And it was stitched together because it was leading edge technology. There were no so-called enterprise system which you just can get in the data center, turn it on, and continue operating. And that's the key we're referring to AI ready. Nowadays, I don't think that term is very much used these days anymore, because everything has become AI ready. Well,
That's not saying.
but if you take a few years back, that was pretty new.
Yeah. Okay.
So we brought, for example, we enable customers in the enterprise customers to use AI infrastructure without dealing with supercomputing, hardware and software, and all the I'll say it.
So basically,
Disadvantages for the operational overhead.
it's just all software driven.
In the end, the whole Pure platform is software driven, but with very efficient hardware underneath. Yes. Two things, or three things. One is the as a service model. That's not something new to us. You've seen the growth rate of that. It's tremendous growth, but we launched that in 2018. So we have a lot of experience already with the as a service model and how to deal with that, what customers want, and we're expanding that continuously. The other thing is, there is something in the industry which is a trend, and that's, okay, how do we modernize applications? How do we run applications everywhere and make them run independently from the underlying infrastructure? And that's basically where the notion of containerization comes up. So, get your application to a container, and suddenly you can run it everywhere. On-prem, you can run it in the public cloud, you can use a public cloud managed service, you can run it in a hosted environment, and so on and so on. But these applications do need the same data services as traditional applications. They need backup, they need HA, they need encryption in an ideal case per application, and so on. And this is why we acquired a company called Portworx, which is container native storage. So that's purely software in listing containers, providing data services to a containerized environment, independently of the underlying hardware, independently of the underlying Kubernetes distributions. And last but not least, the pure E family, here reflected as pure FlashArray-E and FlashBlade-E. These are the platforms where we target the last bastion of the data center in terms of storage, which is hard disk. So we believe in the mission of having an all-flash data center, but there is, well, one last thing, which is the cost burden, because hard drives are usually cheaper than flash drives. And with the E family, we're targeting exactly this market because the price goes down from an acquisition perspective, and over time, flash becomes cheaper than disk to operate because all the environmental efficiencies like power consumption, lifetime of the systems, and workspace products.
So if you look at your multi-year strategy, as you pointed it out, yes, now the next move will probably be software again, right? So you started with the FlashArray, you're now back into launch of FlashArrays. So the next moves will probably be more on the software side, more on the cloud side, probably.
Well, we're doing things already in that perspective. So, you mean because we just recently launched hardware platforms, it's now time for software? I'd say that's an obvious circuit, but what we're doing in terms of cloud is so on, but it's not there. It's not on that side. But we announced a partnership with Microsoft to have the Azure VMware solution in the cloud together with our offering, which is called Cloud Block Store, which in essence is our storage software tailor-made to the hyperscaler's hardware and offering all the capabilities in the home.
So you said the Azure
VMware solution.
Is it only the Azure VMware solution, or
No, it's in general providing the storage capabilities we bring for customers on an on-prem system in the clouds. So we're targeting today AWS and Azure, but for Azure VMware solution, it needed the Microsoft and the VMware partnership to get into that, and we're now the first and only enterprise block storage offering for Azure VMware solution, which is, I would say, nowadays even more important because customers are using this as an interim step to go cloud native in Azure. They're using it as a step to just get rid of data centers and, for example, drive application modernization initiatives, because we know even there are containers available, even there is cloud native, doesn't have implement. And some things you might still have in 5 years on a traditional VM because it doesn't make sense to port the application. But I think we talked about this briefly, but to give you a few data points here or a few items, what we mean by products never obsolete. It's really that subscription piece. You put in a system into your data center, you give it a name, you put data on it, and you can just refresh it almost whole lifetime. And if the data stays there, the identity stays there. And also we were talking briefly about the last announcements. We just underpin that with SLAs. For example, we have a no data migration guarantee. That means if you're upgrading, for example, a FlashArray//X to a new FlashArray//X, so the next generation of FlashArray//X, we guarantee you that you don't have to do any kind of external data migration. Because think of it, what happens in the storage industry if you refresh a storage system. You buy a new system with new drives, with new capacity, put it in the data center, and then you start a migration project to migrate the data over from system A to B. And depending on the system, it can take days to weeks to months, which also leads to you need more rack space in data centers, you need data center space, you need more power, and you have risk in terms of migrating data from one piece to the other piece. And we're just getting away from that list.
Does that mean that you will happily support 10-year-old hardware if people have set something up that works 10 years ago, and they don't want to upgrade it, you carry on supporting it?
It's a yes and no. So if you're under a subscription from us, from an evergreen forever subscription, because it says, well, your system stays there forever, and it's an active subscription, we make sure that the system, which is hardware and software, is supported.
Yeah.
Full stop. So that doesn't mean, for example, if you are using 512 gigabyte SSDs in the system where we started 10 years ago, well, we do support them under the contract. Does it make sense to operate them? Probably not anymore. But we're helping your customers to refresh those older hardware pieces in terms of giving them credits, for example, even for capacity.
So it's customer choice. I mean,
It's customer
yes,
choice.
it doesn't make sense not to upgrade it, but you might not want to upgrade it tomorrow.
Yeah. So as I said, with Evergreen Forever, it's our obligation to make sure the customer has a support system, full stop. Whether there are end-of-life components, as an example, whatsoever, it's on our part to replace those.
Do you accept any liability if by any chance it doesn't work and their system falls over?
That doesn't happen.
And that doesn't happen. If it did, would you accept liability?
Well, that's to T's and C's. We have to dig into that. But in the end, we make sure we support the customers. And that's also down to telemetry data, because we see, okay, these 10-year-old drives, as an example, okay, they have huge wear and they will fall off the cliff within the next 6 months.
Yeah.
We will then proactively reach out to the customer and get this stuff replaced before something happens. And that's the whole notion of the proactive support piece. That's why we have telemetry data to exactly get that done before something bad happens in an ideal case. Right. Power and space. So it depends on which system you look at, but in general, typical configurations tend to be 2 to 5x more efficient than competitor systems in the flash space. And in the disk space, well, it's obviously more because there are racks of disks where you can just replace it with 10 flash system in the end. And you talked about the service model. And this is something which also is something we announced during the last announcement. We have a paid power and rack. So that means if a customer subscribes to a storage SLA, I need a petabyte of pure storage, I want to get it as a service, I pay for what I use. We have a vital interest of getting them very efficient and new technology into the data center, because we pay upfront for the power consumption of the system for the duration of the contract, as well as we pay for the rack space. So it's not that we take a look into our warehouse, which are the oldest systems we have, give that to the customers. That's not the case. It's really, we have a vital interest of getting them very efficient systems, as well as giving customers something which is also pretty important these days, is to assess how they're doing with sustainability. So what's their carbon footprint of that kind of infrastructure, and also make sure that their sustainability reporting systems can be fed. We talked about the less labor to operate. We dug into that with non-disruptive notion, but in terms of, or in times of cyber attacks, we have to make sure that we have an infrastructure which can be updated when it's needed to be updated. Because an attacker doesn't wait for your upgrade window, which you have every 6 months or so, because you have to schedule that time. If there is a severe attack, happening and there's a patch available, customers want to patch immediately. And this is what they can do with Pure. So we made it pretty easy for customers nowadays to upgrade their fleets because they can specify in policies, hey, with these kind of systems, are they leading edge? Because I want to have every piece of new software innovation on these systems. And with others, they say, okay, this is the lifeblood of the company. I would be a bit more conservative. I will be on a long life release, which has been out for a few months already, deployed with thousands of customers and so on. And if something happens, you get an alert, hey, you can upgrade the system. Here's the recommended version. Press a button, and it's really press a button to upgrade the system and also what. There's a few guardrails around that with two-factor authentication, so nobody unauthorized can press that button, but you get the idea. Instead of, hey, every vendor claims non-disruptive upgrades for software, but the reality is, yeah, you generate a 200 pages PDF, you follow the 100 steps outlined in that PDF, and if something goes wrong, well, okay, call support, and then you're in trouble. And we made that to a really simple way of upgrading the infrastructure. And the vision behind that is, can we get something, for example, like your personal computers, but it just upgrade?
Do you offer a training facility to help customers choose the best policy? Because some people will be able to do it alone.
Yeah.
But some people actually want to have advice on what the right policies are.
Yes, so, well, we do this basically with everything. We try to get away the knobs and dial wheels from customers and come up with reasonable defaults. For example, these policies, we have outlined 3 default policies. We think the majority is a balanced one, which is not that super conservative one and not that bleeding edge, so it's in the middle. Being on a long life release, but being on the, I would say, we have 2, to go into that, we have 2 software trains which are long life releases. So one is based on a new feature, the other one is the more conservative. So the balanced one is, for example, being on a long life release, but the newer one. The super conservative one is being on the long life release, but the older one, because the new one has been on the market since 9 months, as an example, the older one since 2 years already. And this is what we pick for customers and make suggestions what they should use. Also for patches, as an example.
Customers should be doing a risk analysis on what they should be choosing.
Yeah.
Do a risk analysis, they must have the right sort of information fed in and some knowledge of risk analysis. But I'm sure there are some customers that don't really understand risk analysis and don't know what factors to put in there. So they could need a handheld. I can imagine a customer doing something stupid like saying, but I have critical systems to always be on the cutting edge release. So it's the most important systems.
Yes, and well, this is customer's choice, right? But even on the latest leading edge release, it's a fully tested Q8 release, and so and it falls into the same statistics, by the way. We provide the 6 nines plus availability numbers and so on. That's all systems. That's not just on the stable or long life release. No, including all these upgrades, by the way, including software upgrades, including hardware upgrades. But it's also, think of a customer using web consolidated storage, which means it's doing block and file protocols. If that customer does not use file protocols, but there's a fix for something in the file protocol stack, he doesn't get that recommendation to upgrade because it doesn't apply to him.
Yeah.
If there are fixes in, for example, some whatever OpenSSH stuff or whatever, he gets the recommendation because that's security related, and depending on his CDSS score, it might be a good reason to upgrade.
Don't you have a co-pilot yet?
Well, this is recommendation driven. We don't call it Copilot. And
You just call it recommendations.
we have recommendations, for example, for software upgrades, but also for hardware upgrades, because we predict that, okay, if that data growth is continuing over the next 6 months, your system will be impacted by either performance or capacity, and make a suggestion to the customer, hey, either you get some workload off that array and put it into another array because there's plenty of space towards that. Or, hey, you have to upgrade that system, and here's a recommendation to which system you should upgrade to have, let's say, 18 months of operations. And here's a button where you can request a quote.
Okay, and who understands that? Well, that's the problem, because there are not enough skilled people. So
We try to make it as simple as possible, obviously. And that's the thing, because nobody in the storage industry can say, okay, if I continue that workload, I need this for the next 18 months. And this is where the whole machine learning and AI stuff comes in, because this one can predict that. And it's pretty accurate. It's never 100%, obviously, because also requirements can change, but it's pretty accurate because we have evidence that we presented this recommendation to customers, they upgraded, and then we do a before and after comparison.
okay.
To tune our models, because in the end we have to also tweak and tune our recommendation engines in the back end. Yeah, we're doing that.
Yeah.
So they understand it, because most storage, I would say, operations is still by Excel spreadsheets. By Excel spreadsheets.
Oh no,
In many
God
cases.
forbid.
In many. Capacity planning is
Oh, no.
one, and this is something we try to get rid of with these things.
Right. Good luck with that.
Well, our customers are happy as soon as they discover these functionalities, because if you have it, you have to use them, because we are all humans, we fall into our habits, and that's more a problem. It's not a technology problem, it's more a social thing of adopting stuff, which is
Businesses can actually run down. I know you've got experience that. Businesses can actually go downwards.
Yeah,
I know that's not an experience you've had, but you also offer downgrades.
well, that's subscription.
So once I'm on a subscription level,
Yeah.
I'm there forever.
No, you are.
Even if I don't need it.
You are. That's the beauty of the storage as a service piece. It's applied, for example, for 12 months, because you think, okay, my business can grow, but what happens if it doesn't? So you don't need a petabyte, you suddenly need half of it. Then you can subscribe for the next period to half a petabyte. And that's the flexibility you have. You don't have to sign a 5-year contract. You can have short-lived contracts if you think your business is more volatile, or there will be the next 24 months will be rough. Don't do capex purchases.
They to subscribe for everything.
No, forever is just a term we're using for the technology piece. So it's a system which you can have modern forever. The other one is the storage as a service piece, which is called a.
Is there an issue with compliance in that you can outsource execution, but you can't outsource responsibility or accountability? And there's a danger with this AI and software operation that you make it so easy that you de-skill your customer, and they're not really in control of how they're regulated to be in control. All they can say to the regulators are, yes, we're confident this stuff is kept secure because we use pure laws and recommendations. Like, imagine the regulator not accepting that has an argument, putting a bit more detail than that as to why they're confident that.
I think the de-skill thing is a huge problem in the whole industry, right? Because it's getting more complex. People tend to outsource stuff. We see daily news, what happened in the cloud, or which mistakes people did using the public cloud, for example, having access keys on GitHub, and then you can get that stuff. That is an issue in general. But the other thing is we don't have enough labor to operate all that stuff.
I mean, in days
We're
gone
not
by,
getting it.
I hit this problem in an organisation, a bank, that was critically dependent on people who weren't employed by the bank and had the skills needed to keep the system going. They could virtually dictate what their pay rate was. And if they fell under a bus, it was tough. I remember my boss saying that I know that being a bank employee is supposed to be a good thing compared to consultant, but the only Rolls Royce in the car park belongs to one of our consultants.
Well, we see also, just looking at the time here, at some customers we see exactly that, because there was a huge wave of outsourcing, which de-skilled their people because they don't have so many left. And then now reskilling people, hire people again. So I would say that's the other part of the wave we see at large customers, that they get in people, skill them up to do operations and not just rely on externals. And we see those waves in different to different extents, right? It was first about outsourcing, now we have pieces of tasking. Even you could say the cloud is something also out-tasking, because suddenly you don't have to operate a data center, which is different to the cloud. On the other hand, still security, compliance, governance, these are the same things you have to follow in public cloud, in an outsourcing contract, as you have to run operating this everything by yourself, right? So, in general, I think it's an issue, right? To have enough skilled people to do all these things. And if we take a look, for example, at ransomware as an example in cyber threats, think of what AI is doing. AI is great, but it becomes more attractive for attackers because you're doing something with AI, which could be pretty interesting for me to add. We had that notion of script kiddies 10 years ago. Now you just use AI to write a piece of code to exploit something. Only the room can do that. So
It's the same cycle, right?
it is.
The good people need to be in front of the bad people.
Yeah, it's always this cat and mice thing in security. But what we can do for our customers is to make it, I would say, security ubiquitous in every aspect. One thing is, for example, the ability to operate. It sounds very simple, but in the storage industry, it's not a standard that you can just say, okay, there's a security patch, I implement it right now. With sure you can do that. Also, we protect customers by default, which means every storage vendor now has a capability of doing some immutable copies, immutable snapshots, because immutability is something, it's the first line of defense for ransomware in the storage space. But lots of systems act like, okay, I have a detection engine, and if something is wrong, I will do snapshots, and then you're protected. With Pure, we implemented something which says, okay, as soon as you're creating a volume on the storage system, it is protected by immutable snapshots. It's also protected by something we call safe mode, which prevents malicious attackers and the administrators of eradicating these snapshots from the storage system. So even if a malicious attacker gains administrative access to the system itself by compromising, for example, Active Directory, is not able to delete your very last line of defense, which is the backup. And that's auto-I. And obviously, we try to help customers with anomaly detection to see when did an attack happen and which data sets are affected. Because in order to recover quickly, you have to identify what to recover. And that's also a pretty tough thing. And here we try to get customers, give them the ability to recover quicker. Because in the end, in case of ransomware attack, you have to recover.
The trouble is that AI enables the hackers, just like it enables protectors. And the quality of the hackers' motion of ChatGPT is a lot better than the tools that the script kiddies had available to them.
Yeah, and it's I would say it's a call to action for everyone to keep the systems up to date, because these ChatGPT likes, etc., can write code for known exploits, but not for 0 days as an example. That requires a bit more sophisticated software development to do that. But if you don't patch a system which has a vulnerability since 12 months,
If you've corrupted the Microsoft, say, the patch itself might introduce malware, because patches tend not to be tested as carefully if they look like they're urgent. There's a danger that testing gets skipped a bit, and therefore you introduce malcodes with the patch more easily if you're telling them.
yeah, and that's something in the back end, what you have to do.
Yeah.
You have to maintain a proper software bill of material. You have to do threat modeling for everything you do. And that's basically a huge change for the engineering process, because back in the days, what happened? Engineers developed a piece of software, and afterwards it got checked against vulnerabilities. That was the status quo.
Yeah.
Nowadays, before any kind of code is written or library is used, it's scanned. Okay, we want to use this library. Okay, is it secure to use that library? And not just from a licensing perspective, but also from security as well. How do we do threat modeling for everything? We develop. We're constantly pen testing our scope, and not just when the software is finished. And this involves a whole change in the engineering. But you have to do that as a vendor, because, like you said, there is a chance. We've seen supply chain attacks to get malicious code in your code, and then you deliver it to a million of mistakes.
So,
Sorry, can I ask a question? Sure. Just for clarification, because I'm not fully into this, especially not your system. No problem. But when you say, even if an attacker, say with ChatGPT created code, attacks my server that I installed in your system, started with multiple Windows servers and Active Directory and one. And you say you take a snapshot. That is out of the system. That's a completely different level, right?
I mean, it's in the system, but you can also, for example, that's a first line protection to have snapshots on the same system you're hosting based. Because snapshots are
It sounds like you're going into the customer's system.
No, we don't. We just do this on the storage system. So think of a snapshot as it's a Polaroid picture. You take it from the current data set.
Yeah.
And this one is an immutable, logical copy of your data hosted on the system.
Yeah, that's what.
And we protect this copy against deletion from an administrator account.
Was that? Yeah. Okay.
Because, for example, if you compromise an API key, or people tend to use simple passwords sometimes, or whatever, there's a chance that even a malicious account or a malicious attacker deletes this immutable copy, and then you have nothing. We protect that copy.
Yes. Okay. But
that's on the system, and the purpose is that's on the system is because recovery, it's a logical copy of the data. It's really an instant recovery. It's a snap, and then you promote this snapshot, this logical copy, to the active system. So you can just continue operations. That's the ideal case. You can also get this data off to a backup system where you have the snapshots and the immutability things implemented, and then you can just recover with your backup software to primary system. But that takes longer, obviously, because you have to recover data from one piece of hardware to another piece of hardware. Right? But that's not on the same system. So this is something where you have your primary systems, you're doing snapshots for quick recovery, you're doing backups into, for example, another data center or a fire zone or whatsoever to protect against loss of the physical system. But you also need to protect backups.
Okay. And follow-up question. When you say that there's ability to create malicious code to go into a system, that would compromise a customer system. I understand that. Microsoft systems are like out there. I would expect ChatGPT to know probably how to write code. But the software you provide that runs the servers, you feel that ChatGPT will probably know about it and can write code for that as well. So your system that you actually provide for the customer implement the service.
Well, it's another question. It's always a question of what's in for the attack in the end, right? Because if I target pure storage customers, they're 5,500. If I target Windows customers, they are millions. So I have a larger lever in it. More vital, I would say, interest in attacking the broad scale. If I have an interest as an attacker to compromise this particular thing, that might be a difficult thing. But yeah,
The most risky thing is that the target attack.
You know, if
yeah,
I can
it's a
jump in,
target attack.
sometimes I feel like we're going way too much into technology because there are many ways you can just bypass, you know, if you do social engineering or whatever, or pay an insider, you can just bypass a lot of the technology things. So I think to me, the key is the resiliency and the recoverability of the data, because you might get impacted in one way or another. So ensuring that the data you can get back to a point in time where the data is sure that you can have the proper, let's say, DR architecture and cyber resiliency, because again, we're not in the case of operational recovery where you're hit by a disaster or outage or whatever, and you need to recover. Here, you also need to check the integrity of the data. So you need to make sure that you test whatever you need to recover. So I think that and the other aspect to that is that in the case of a social engineering attack, for example, if I'm compromising an administrator account, some of the capabilities that you have, such as multi-administrator validation, ensures that you're not able to immediately go and delete snapshots or change snapshot retention policies or whatever, because in the end, the first thing an attacker will do is disable or try to disable the data protection infrastructure, so you cannot recover and you're forced to pay the ransom, right? So that's kind of the idea.
Players make paying answers illegal, but you've got to test your procedures, and you've got to go right back to the level of coercion control, because if you get the physical security better and better, there comes a point when going up to an authorized user and sticking a knife in his throat and saying, you know, log me in and transfer this money is the only viable way. And the targeted attack on a large sum of money, why do you do it? Why do we rob banks? That's where the money is. If somebody comes against you, targets you because you've got lots of money available, they will then to stick a knife in the throat of your wife, your kids, or you. And you have to make sure you've got coercion control. You can't just rely. This is well outside your scope. You can't just rely.
That's true. That's a bit out of scope. But really, what I think you described it perfectly. What we can do is we can provide customers with, yes, you get data to recover from, because it's way simpler to do a social engineering attack than writing a software exploit for a specialized system. And even we have to be resilient against some attacks. For example, many systems are using open SSL libraries for encryption or open SSH, right? If that's getting compromised, we have to make sure that data is still there, because it can happen, right? We've seen attacks like Heartbleed as an example against SSL. that affected suddenly probably every system in it. What are we doing against that? Things like Log4j, another example, which can happen, that impacted suddenly billions of systems, and they had to get patched. So even we patch that, there might be a chance that an attacker already compromised that. Like, we have to make sure that the infrastructure is resilient enough so customers still have access to data, even if the system is getting compromised. And as you said, attackers tend to delete the primary system, but also disable and delete data from the PR systems and from the backup systems. Because otherwise, there's no point of paying the ransom. Because you say, I can recover my backup. Yeah, it takes a few hours, but still pay the ransom. This is something we want customers to be in that situation where they can say, okay, I don't pay the ransom because I have data available to the account for. Yeah, we've seen that. It leads a bit into a comment you made earlier. Yeah, there's a software cycle probably. And this is really what we do is we tie hardware to software. So Purity is the name of the operating system on the systems themselves, on the storage systems. And we got this thing here, which is called the direct flash module. So what Pure is doing is we're not using off-the-shelf SSDs. We're developing our own flash drives, which surprisingly look a bit like an SSD because in the end, there are very similar components on that thing. But what we don't do is these drives compared to SSDs do not run software on that. So there is no SSD control, no microcontroller on the system doing all the garbage collection and wear leveling and all that stuff on the drive. And maintaining large tables of metadata translations from host blocks to flash cells. We offloaded that into the operating system. So we have a view, the system has a view about every flash cell in the system deployed. See?
Can I just say, because these guys are asking so many questions, you're not even halfway through the slides and we have under 20 minutes to go.
So I have to hurry up.
That doesn't mean don't ask questions, it's just bear that in mind.
Okay. I think it's your fault. No, all good. So we offloaded that to the operating system, all these functions, and what it gives us is we just celebrated, I think, the 7th anniversary of this technology. Is the flash cells have a longer lifetime. That contributes to sustainability and also to operations. We have way larger densities than every other vendor has. Just yesterday, a vendor announced new storage systems, and the maximum QLC drive is 30 terabytes. We're shipping 75 terabyte drives in volume for a good 6 months or so. And we've outlined a roadmap to 300 terabytes in 2026. So we will double to 150 and then double again to 300. And the beauty of it is, it's same form factor as a 256 gigabyte SSD drive. It has the same power consumption as that drive. It has the same physical needs in terms of rack space as that drive. And this drives also the sustainability agenda, as well as it's way more efficient because we're maintaining the metadata, we're doing the well leveling and so on in the operating system, which leads to we using less power in the end for the capacity, and we can build way dense systems. And what's the capacity again? 75. 75 drive.
Not bad.
And we're shipping these in volume because every vendor can make announcements, hey, we have these kind of things, but these are shipping really for volume for customers. So again, this is where the hardware technology is based. We brought the features of the software to the cloud with an offering called Cloud Block Store, which is powering, for example, Azure VMware solution on Azure. It's also available in AWS. We have the cloud-native part with Portworx. And then we have something which we're calling a cloud operating. What does that mean? We have some, I would say, ideas into subscription, because that's something you have in the public cloud. You don't buy systems, you subscribe to services, and you get SLAs for that. But how are you doing this with on-prem infrastructure? Because you might have different systems for different needs deployed. So FlashArray has a few permutations in terms of performance. So we got systems where you have very transactional performance, where you need the lowest latency, highest performance, and you get a FlashArray XL. You got needs for moderate performance, which are more cost optimized, and you got FlashArray C. And you got some archival workloads for big content repositories where really money matters, and you got FlashArray D. All running the same software stack, all offering the same features. So in the end, well, why not have an umbrella over that and have a common management model? Because I said it's very simple to operate a storage system on Pure. But what if you have tens or hundreds of that? It becomes complicated because you have to maintain which system has which capabilities, how we utilize which system. And while we help there, it's still a choice of a human to say, okay, I want to do this on that particular system. What the cloud operating model really means is to put an umbrella over this and make a data storage cloud out of it. Which means you get a single interface to your whole storage fleet, whether it's on-prem or in a hybrid model using Cloud Block Store. And then you say, okay, I want to provision a piece of storage because I need a few terabytes for an Oracle database. What you usually do is, okay, you say, okay, Oracle, the systems are applicable for Oracle workloads. There is enough space. I look into my system, how utilized it is. Okay, that should do it. I get a recommendation, and then you say, okay, I need it. What are you doing with the cloud? You say, I want to deploy Oracle. You pick the storage, okay, fast. You maybe pick a region where you want to deploy it. Yeah, that's in Munich. And the next thing is you have a protection scheme. Okay, I want this to be, I want to have snapshots, I want to have SafeMode, I want to have synchronous replication to another server, whatever, and next. And you don't care which system it is, because you even don't know what kind of hardware it is. And this kind of abstraction we want to bring into the Pure world. So a customer can have, for example, can make templates. A Oracle looks like it must be on the fast tier. It consists of these kind of this number of volumes, this quality of service setting whatsoever, and then give the consumers the choice. Okay, I'm a consumer. I want to roll out Oracle. I get presented with let's call it a menu, service catalog. I add a region. Using the same terms of public cloud, you get regions and availability zones, and you say, okay, I want to deploy this in this availability zone, next, done. And the optimal infrastructure piece is chosen by a layer called Pure Fusion. That's just the software, that's the name of this engine, and then it's put into place. And this is not just for a data center, it's really meant to be fleet-wide. So in terms of, instead of managing individual systems, you're exposed with a service catalog for the whole platform. which you then can consume, which is really like a good you consuming storage in the public cloud. And if you compare that with a storage as a service model, and on top of that, you can really say, okay, it's all balanced from an infrastructure perspective. You have buffer everywhere, and if you run into the buffer, you're getting a notification, hey, you're now in the buffer, you may have to expand the systems or whatsoever. So it's really meant to gain more efficiency, operational efficiency, and it's automation where customers don't have to automate everything. Because that's not something new to pick the right piece of infrastructure, right? You've heard that probably. But it's very complex to implement for customers to do that by themselves. So instead of doing, I would say, 1,000 lines of code doing automation, you just need 100 lines or maybe 50 lines of code to do that. And the rest is done by infrastructure, and the right piece is chosen because, as I said, often capacity and performance is managed by spreadsheets these days. Here you get a recommendation engine which is contributing to that. And this is something, well, we will obviously expand and expose more to customers. In terms of time, I guess you see that that's the advantages we have. It's really fleet management and as a service from a cloud operating model perspective. That's the evergreen model with storage as a service. It's really no technical debt. Your infrastructure is always up to date and you can implement every innovation, every patch in a non-disrupted fashion. Everything. The portfolio, it's quite, I would say it's a slim portfolio because in the end we have two hardware platforms. One is meant for a scale-up approach and the other one is more meant for a scale-out approach, depending on the customer's needs. All, I would say, storage protocols, so all storage protocols needs customers might have. And again, the innovation to use our own flash management and use our own drives gives you more efficiency, reliability, and longevity, which is contributing not just to operational benefits, but also to the ESG agenda. Because you mentioned it, data is growing like now, and there will be way more data every year. There are a few references we add here, but also we have to know a lot of greenhouse gas emissions are coming from data centers, and AI will not make that better. Because we want to use more AI, everybody wants to be ahead of the curve. And we've seen NVIDIA's announcement, 120 kilowatts per rack, which is quite a high number of our energy consumption. What can we do to mitigate this, or to enable customers to use GPU computing better within the same power envelope of their data centers? And this is where we contribute with the systems to it in terms of developing high efficiency systems. So systems themselves are very efficient in terms of power consumption, density, how many terabytes I get out of the box per watt. That's a new measure. Sustainable data center operations means, for example, the storage as a service model. Buy only what you need, or do operate only what you need in the data center instead of purchasing something for 5 years. You may have to predict it with your crystal ball, because that's still often the case. And e-waste reduction is the evergreen model, only replace what really needs to be replaced. And in the end, we talked about the density part, we talked about the efficiency of the systems themselves. For example, also we have to follow some regulations, like the EU now demands, for example, titanium power supplies, which are more efficient than the platinum ones, so you're gaining a few % of energy efficiency here. But also having a modular system which says, okay, I only need to replace the components which really needs to be replaced, instead of getting rid of the whole system and decommission and do whatever with that. That's something we did. And give you an example here that you see that also in the ESG report. It's a combination of technologies which contribute to these large savings. It's the direct flash technology, which we saw in the flash modules. It's built for flash software. So we not have to deal with any kind of hard drive legacy in the backend, translations and so on, because we started with flash and already doing flash on systems. Data reduction contributes to that. We're constantly improving that with new compression algorithms and so on. And obviously, evergreen architecture leads to way better energy efficiency and less greenhouse gas emissions than competitive solutions. The last hardware announcement we made is the Pure family. And this is where the systems look like the same, like everything else, because it's Flash Array and the Flash Blade series. But the target market here is really the market where disk-based storage systems are used. And these disk-based storage systems are used because they're cheaper for these kind of workloads. Because for archival workloads, as an example, or for surveillance use case, usually you're not using high-performance flash systems because they are cost prohibitive for these kind of workloads. With the E family, they are using these super dense flash modules as an example. We made it to the point that the acquisition price is in the same ballpark as storage systems based on hard drives, but from a total cost of ownership, they're way cheaper. Think of getting a 1 petabyte system, which we have in 3U, such a small box. From power consumption is roughly 1 kilowatt for this box to operate a petabyte of raw storage. If you take data reduction mechanisms into play, you might end up with 2 or 3 petabytes of effective storage. Compared to a disk system where you're using 4 terabyte drives or something like that, you have potentially 2 racks, which is 10 times more the power envelope. So over time, it will get cheaper. And also what you have to note is flash, especially direct flash, lasts longer than everything else. They last longer than SSDs, and they last way longer than hard drives. Because the annual failure rate usually for hard drives starts to increase in year 5. And then you have to replace, because otherwise you have the risk of data loss and so on. So every 5 years you have a huge migration project. And migrating from disk to disk is not something you really like to do because it's very slow. And again, it's very narrow. For customers having larger data repositories, if you talk AI as an example, or if you talk healthcare imagery, we have FlashBlade, which scales to tens of petabytes in very efficient systems. So again, density contributes to that. We're constantly also improving the software to make more use of the flash available to enable more effective capacity and drive down the power envelope in terms of power output. I think we talked about the subscription model a bit. Here's an example of what is achievable if you, for example, bought a system in 2012. And this is what it should illustrate different hardware architectures. You had that question. So we started with 2 external rebranded servers with external shelves with SSDs. There was InfiniBand between the servers for an HA interconnect to make it highly available. We changed that in 2015 to an integrated system where we're using NVMe, where we're using an internal interconnect to the controllers, but we still used SSDs. we thought about 8, there must be something better, which led to the FlashArray X, where we changed the complete architecture to be NVMe based. So no more SAS, no more SATA, and no more SSDs, because this is when we invented the direct flash technology. However, we're still maintaining compatibility to SSDs, because customers don't want to throw away everything, throw the investment away. They can just use them as node systems. But then there might be a point where they say, okay, they're getting too small, too inefficient, we want to get to the direct flash technology, and they can. And this is just to, you see the numbers here about what you could achieve, hardware generations, and it's all done on the fly on the Scottish.
Sorry that I really have done today. When you talk about your flash rate in straight,
Yeah.
you're still using, I assume probably from Micron, the actual memories that store the data. You've just taken out the controllers, which is
So if you want to just, well, in storage you have the media and you have the controllers, which are just the computing engines for the storage system itself, right? And why should you change the media if it doesn't give you a benefit? There's no reason why you should do that, right?
I'm not asking why you did it, but I'm asking if it is still an SSD type. If you buy an NVMe today, you get a storage piece and you get a controller on it.
Yeah.
And you stick it in parts, and when you did, you separated that.
Yeah, there is no controller.
There's no controller.
The features of the controller are
So, but you're still using the memory chips.
Yes, we do. Yeah, that's just NAND.
Single level.
That's TLC or QLC NAND. So we're using TLC and QLC systems.
But it's still the same.
It's still the same. Yeah.
And you claim that it lasts longer than HDDs.
Yeah. I mean, that
You have evidence of that. Thank you for that.
Yeah.
I was looking for.
So the annual failure rates are way less than, for example, SSDs and way less than HDDs.
Yes.
And you see that that's what I say, evergreen one, that's our storage as a service, and it's really not just a different purchasing model, it's a service, because we're doing service metering, we're exposing SLAs to customers, we maintain, for example, buffer capacity, we're offering recommendations, not just automatic, but also we have people behind that, customer service managers, who are there, customer success managers, sorry for that, to help the customers getting the best out of that piece of script. And you see, that's all by default. There is one add-on available, which is a ransomware recovery SLA, where we give customers the opportunity to get clean systems and help them recovering data on these clean systems if the original system is blocked, for example, for forensics or so. In order, obviously, to get back to operations very quickly. No presentation without AI. No.
One question for ransomware protection. Do you have integrated functionality for the operating system also for ransomware that it can detect
Yeah, we have some anomaly detection. We also have some software partnerships with software vendors who are doing actions on certain events. So what they do is they monitor our event log, and if there is something malicious, they can take an action. For example, if you log in too often, I detect that and I disable your accounts. Just as a simple example. Lots of AI projects are running on Pure. You see, you may be familiar with some of them, and it's across the board. So it's not just the large language model providers like a Meta. It's also in healthcare, it's in automotive, it's in development, it's in something called pizza delivery, because Domino's Pizza is doing amazing things with AI and data to optimize their pizza delivery service.
Make the pizzas taste better.
But that's that. But taste is the discussion. Last slide, we have our key event upcoming, which is called Pure Accelerate, the week of the 18th June in Las Vegas. And well, I would just urge you to follow everything what we're doing there. If you be there, you're welcome. If not, we will certainly have some press briefings around that event.
Do you have any reaction to the NetApp announcements this week? They're quite comprehensive upgrade to their portfolio, new products and AI and alliances, etc. Do you have any response to that at all?
No official response, but as far as I've seen, it's just a renewal of their existing systems. So
There's new products as well.
well, it's not really.
Okay.
So it's the next hardware generation for them. And the AI piece is the architecture with NVIDIA, which we announced, for example, at GTC as well, so with OBX. So that's what
Fine. Thank you.
Thank you for your presentation. I have one question. What is your biggest challenge at the moment as an enterprise architect in terms of bringing IT strategy and business goals together?
Wow, that's a really broad question. So I think the biggest challenge here is really complexity. Complexity of bringing also business and technology together. And it's not just technology which is complex, it's the notion of enabling people, enabling the workflows, changing their mind, for example. Hey, how do you use AI? How do you get AI into an operation? Because it comes in. But people have fear of AI, and you have to get away that fear. It's the same with other technology because they have the potential to replace jobs. Others say, how do you upskill your own workforce? We have people who are, well, I talked to recently to some CIOs, and they said, well, I got 50 people for my data science team. But the only data piece they were working on were Excel spreadsheets. They have no experience with any kind of programming language or data science project at all. How do you reskill them? And I think that's the biggest challenge nowadays. So how to enable the workforce to use the right piece of technology in a secure way as well. Because, well, if you take a look at what the investments will be in IT, number one is cybersecurity and resiliency. Number two is AI.
With AI, though, it's just two letters. It's not intelligence. It's not sentient. It's another silver bullet which CEOs can pick up and go back home, go to a conference, come back home, take their CTO and say, I want more AI.
Well, what is AI or Gen AI? It's a vehicle to be more efficient in some areas. In the end.
It has implications as well.
It will not end world hunger or whatsoever.
One of my favourite quotes was that you won't be replaced by AI, you'll be replaced by somebody who understands how to use AI.
Yeah, that's probably a good one now.